Hello, welcome to Tech Transform. In this video, we are going to cover Seaborn. Seaborn is another Python data visualization library. It's based upon matplotlib. In my last video, we have seen the matplotlib. The Seaborn is it's very efficient in showing all this visualization of the data sets what you're going to use. So why it's quite popular? It's like that. It can give you the very good representation of data. If it once you are doing a work of exploratory data analysis EDA, and given the big data sets you have, and you want to select the features, what features are more meaningful in order to train your model. So in that case, Seaborn gives you a very good visualization where you can decide, okay, what are the features I have and how these features are actually correlated among, let's say two features I have selected, and those two features are highly correlated. That means we can dump one feature, and we can train our model based upon the only one feature. So that's how you can you can take decisions in feature selections and feature engineering. So let's get started. So we are going to cover three types of plot here: dist plot, joint plot, or pair plot. So let's say I am going to once you install the Seaborn, this tips dataset is automatically installed. This tips is a dataset that is all automatically installed, and it's also Seaborn provide you a data frame capability. Here you can, like data frame in pandas, you can do all the operations related to pandas data frame here provided by Seaborn also. So you can see these the dataset tips, and you can see all those features we have: total bill, tip, sex, smoker, day, time, size. So this tip is basically is our output variable. Means this is not a feature, this is a feature, but these are the independent features, and these are the dependent features. Means based upon total bill, sex, smoker, day, time, size, we have to predict what is the tip, what would be the tip. So tip is the dependent variable, and other columns you are seeing are the independent features. So as I told you, you can see 1 2 3 4 5 6 features are there. So when you are try to correlate your one feature, or correlate two features, that is called univariate analysis and bivariate analysis. In that case, joint plot is useful. If there is a more than one if there is two feature or one feature, you can use joint plot for having to have the analysis of the features. But if you have more than two features, you want to see the diagram, see the correlations between two features, then definitely you have to go with a 3D and 4D or 5D diagram. So that's not it's common with the human human brain. We cannot see all those 4D and 5D. So that's what where comes the pair plot. So pair plot will give you an interface where you can see how the more than two features, how it's correlating with other features and all. So dist plot is basically for meant for only one feature. If you're trying to see how if you try to analyze how your data is distributed, then you can use dist plot. So let's get started. The very first thing we are going to do here is import Seaborn as SNS. We are importing our package. Then this Seaborn comes with a load underscore dataset inbuilt method, where it is going to load different datasets. So its tips is actually inbuilt dataset. So you can create data frame by using this tips. So you can see we have tip df.head. These are all the methods available in pandas data frame also. Same methods you can utilize over here also. You can see these are the columns we have. Tips is basically the independent dependent variable, and all other features are dependent variable. Means tip is going to decide based upon these other features. You can see that what are the types we have for these columns. So these are the float. These are the categorical data, and this is the integer data. Okay. So here we are try to find the correlation. So correlation, guys, it's very important. Why? Let's say if you have two features, let's say it's data frame is come inbuilt with the .cor function. That's basically it's a correlation function. So this is very important in exploratory data analysis or feature engineering or feature selections. So let's say we have this I have total bill, there is a one feature, and you see I passed whole the data frame, but it is going to give me only the correlation among these three columns only, these three features only, because this is correlation is going to work on the numerical or float data types columns, not on the categorical data type. So for this we will see in my upcoming video, we'll see how to handle this. So here it is going to take only give you the correlation between the. So here we can see how the different features are correlated among them. So you can see total bill, it itself it is going to correlate highly because we are relating the same total bill with the total bill. So it's so correlation is basically concept in statistics. You can watch other videos of how correlation. So here basic concept I can give you, it range values will having, well, it lies, the correlation values lies between -1 to +1. The -1 is the less correlation between, means those two features are highly not related. If you have a feature is going to tends to 1, means if let's say if your correlation value is coming 1, it means those features are highly correlated, means actually you can replace either you can dump one feature, or either you can replace one feature with another feature, because it is not going to affect the model. So that's how it is correlation concept says. So you can see total bill is related to tip. It means it's positive, it's coming positive, means your total bill is increasing, your tip is also increasing. Based upon size is also coming positive. So we can interpret like if total bill is increasing, our size, number of visitors for that particular restaurant is also increasing. Also, let's say if this value of tip if it is coming in negative, we can say the tip is decreasing, the total bill is decreasing, the tip is also decreasing. So that's how your tip is this tip variable is correlated to total bill. And see, you can see how it is related to. So the values will be lie between -1 to +1. So all the values are positive, means the features are increasing, and corresponding the features we are going to relate is also increasing. How we are going to correlation with the heat map? Heat map is basically the same correlations representation in the visualization way. So heat SNS Seaborn is providing you the heat map method inbuilt, where we can pass like this sns.heatmap, and we can pass the actual correlation. See how it is giving you the visualization presentation. So it's total bill. See, total bill is, if we are trying to find how this total bill is related to size, we find it as 0.5 and it's going to 1. So means 0.5 is less related, but having value 1 is highly correlated. So you can see total bill, if we want to find out how this total bill is related to size feature, we can say the value is coming from 0.5 to 0.6. So this is how it's related. And also you can see how this tip is correlated. Tip is coming tip is related to size is also highly correlated. It's coming from 0.5 to up to something in between 0.6 to 0.7. And you can say if you are correlating total bill to total bill, so it is coming maximum, because we are comparing the same itself, the total bill it's comparing to total bill itself. So that's why the value is coming highly correlated. So that's how you can understand how the different features are correlated among them. So that's give you your human brain can more take perception from the pictures rather than data. So we can understand from this heat map. Now it's come joint plot. Joint plot is used for univariate or bivariate analysis. Univariate or bivariate analysis means once we are trying to find the correlations between one feature or two features, that's called univariate or bivariate analysis. The joint plot is for that. You can use bivariate or univariate analysis. Like see, you can see here sns.joint plot. Here we are passing I am passing two variables here, two features. One is x-axis is going to contain the tip feature, and the y total underscore bill is going to show the total bill feature, and we are passing the whole data set here. Data is equal to df and kind is equal to hex. Let's say if we want to, if we don't provide this particular parameter, how this looks. So this will come as a normal scatter plot, dot dot, it will come as a dot dot. If we want to give better representation, it comes like this, hex. See, so by looking this joint plot, what you can interpret, guys, so you can interpret basically x-axis is tip, your total bill is on y-axis. So you can see the data, this is the histograms for tip. In last video matplotlib we understand what is histograms. Basically histograms are it will give you how your range values are having the density. Let's say from 0 to 2 you have less values, how your values are actually densified, means how your number of counts for your value. Let's say 2 to 4, the number of density coming like this. So here you can see the buildings or the size of this histogram is high. So we can say the distribution of data, the higher the size, we can say the higher the range of the data available in our dataset for tip. And you can also see if you compare here and if you compare the total bill, you can see from this range to this range means for this size 10 to 20, your tip is actually very high. Your total bill is coming from 10 to 20 to 30. Your tip size is also, you're getting tip, your tip is also high, because here you can see this total size is also high, this density is also high, this density is also high, the intersection is this. So here we can say the concentration of the points are here more. So here we can say the total bill and tip is highly correlated in this range of total bill and in this range of tip. So that's how joint plot is giving you an overview. If we are changing the value of kind from hex to reg, so what it will give, it will give you a regression line, and also it is going to plot a curve of normal distribution. So this is how normal distribution curve is, it's telling you how this data is normally distributed. Pair plot. So in last joint plot what we saw, we tried to do univariate or bivariate analysis having one feature or more than one feature, only two features. But if you want to do analysis, or if you want to find correlation among more than two features, the pair plot is used. So the syntax is sns dot pair plot, and we are passing the data frame here, our data set. So you can see what it will do, it will apply the permutation and combination. It will it will take one feature and it will give you the correlation among all the rest features. So it will apply permutation combination and it will give you the correlation between among all the features. So let's say here we can say total bill, how it is related. Total bill is related, see this is the histogram of total bill. Here we are seeing how this total bill is related to tip, related to size. So remember again, once we are trying to pair plot, it is going to take only the numerical or float value. That's why we are able to see only total bill, tip and size correlations. So here we are here we can interpret that, okay, in this range, in 15 to 25, my total bill is high, means the distribution is very high here, means more bills are having this much, more bills are coming in this range 15 to 25. If you want to interpret something, we can see, okay, the tip is also increasing, so we can say total bill is increasing, tip is also increasing. So like way we can find the correlation between other features also. Okay, and let's say I want to print this this pair plot in respect to my a sex column. So sex, I want to know how the data is distributed among female or male member. So for that we can use sns.pairplot, and there is a one parameter called hui. Hui, if you pass a categorical data, your like sex or a smoker, also we have a categorical data, it will give you the data distribution based upon that sex. So see, if sex we have male and female, so we can say from here, we can say the tip provided by the female member is higher among compared to the male member. And also we can see how the data is distributed, how the tip has been given less tip and high tip, who has given this, and basically these are the outliers. So this is a very best way to categorize data based upon categorical data, and we can saw even the pair plots. Dist plot. Let's say I want to see how my particular feature, single feature, is distributed. How means it will basically give you, this plot is basically give you a histogram. Here you can see this is your tip value from 0 to 10, and these are the range from 0 to this. Tip has been given from starting from, let's say, 1 to 4. So these are the range from 1 to 2, how many persons have been given. So these are the percentage, 0.1%, 0.2%. So this by default, if you do, it will come in 0.1, 0.2, 0.3, 0.3. So these you can say in percentage. But if you want to see in the numbers, actual the count, you should do the KDE is equal to false. There is a parameter. By default it is true. That's why you're seeing the normal distribution curve also along with that. If you want to disable it, simply set the value KDE parameter to false and bins 10. So here you can see the actual count. So 0 to 2, number of counts of 14. So so from the tip amount from 0 to 2, they 40 members have 40 persons have given. So that's all. So we have covered all the plots, and also we saw the correlations, heat map, joint plot, pair plot, and dist plot. So, and what are the uses of that in feature selection and exploratory data analysis. So that's all for this video. Thanks for watching. Have a good day. Bye.